Okay, so in this video I'm going to quickly talk about just a few of the key points we went over with parametric equations. In our Unit 8 we didn't go super far into parametric equations, but we did talk about how to graph these by hand and then on our calculator, and right now I'm just going to kind of run through a reminder of how to do that on the calculator. And then it says then convert the equations to rectangular form. So I just want to review one more time how we can use substitution to take parametrics and write them in rectangular form. So if I want to graph parametric equations on the calculator rather than creating a table of values and plotting points by hand on the TI Inspire, then instead of entering a normal function, because I have two parametric equations here, one for our x and one for our y, if you go to menu and go to graph entry edit 3 and then to where it says parametric, which is 3 again, then it should pull up an entry for you to enter parametric equations. So for our x equation I'm going to type in 2t plus 1, and we're going to use t here because you can see that it's using t as our conventional parameter. A lot of times time is going to be our parameter with parametric equations. And for our y equation, 3t minus 2. Now it's really important also to pay close attention to your interval for your t values. So we're going between -3 and 3. So I also need to adjust those right here. So I'm going to say from -3 to 3. Oops. -3 to 3, sorry about that. Okay, and then I'm going to press enter and graph. And it looks like it's a line. I don't know if I can see the whole thing. A lot of times, again, with parametrics, since it's starting and stopping at different t values, we probably can see that in our graph if we look at our window a little bit differently. So I'm going to just zoom out a little bit. I could adjust manually, but maybe if I just zoom out, yeah, I should be able to see most of it. So you'll see that this is where our graph is starting and ending. If you want to trace to see that direction, as time goes by and I move forward and time's getting bigger, we're moving in this direction. So this is our beginning down here at t equals -3, and this is where we end up at t equals 3. Okay, so here's how we graph on the calculator, and we see the direction, and then we could either match that or draw a sketch or whatever we're asked to do beyond that. If I need to convert them to rectangular form, remember that just means back to like a regular equation with x and y where we have eliminated our parameter. So we want to eliminate t. So I'm going to do that by using substitution as a strategy. So I'm first going to just take this x equation and I'm going to solve for t. So I'm going to subtract 1 from both sides and say x minus 1 equals 2t. And then I'm going to divide by 2 on both sides. And so that means t equals x minus 1 over 2. So I can take that t value and I can substitute it into this equation and say y must equal 3 times x minus 1 over 2 minus 2. And now I have an equation that would be in rectangular form that only has x and y. If I want to simplify this a little bit to get the equation of a line in mx plus b form, I could say y equals 3 halves times x minus 1 minus 2, and then distribute 3 halves x minus 3 halves minus 2. And if I create a common denominator there, I'd have 4 halves, so I end up with -7 halves as my y-intercept. So this would be the equation of our line in rectangular form. Now, it is not the entire line like you can see in our graph. I don't want the entire line all the way from -infinity to infinity. So let's see what our domain restriction here is within our t value restriction. So if I plug in these t values here, I should be able to find the corresponding x values that I'm starting and stopping at. So if I plug in the first one, x equals 2 times -3 plus 1, I would have -6 plus 1 is -5. So when I'm down here at t equals -3, I am at an x value of -5. So my graph is going from -5, and then we want to figure out where is our domain ending. So I can plug in this end, 3, and say 2 times 3 plus 1 is 6 plus 1, which is 7. So I know that I want to restrict my x values between -5 and 7, and this would be my answer in rectangular form. And let's just check now, since we already have the graph up. Hello. Oh no, my calculator just died. Oh no, there it is. Sorry about that. If I trace using graph trace, I can go to where I'm at the end here at t equals -3, and you'll see, yep, there's our x value at -5. So I'm going from over here at -5 all the way to, let's see, on the other side when it's +3. Here I am at x equals 7. Looks good.